All right, guys, Mr. Jenkins here with lesson 6.6. And today we're going to be learning about function operations. Okay, so just kind of combinations or compositions of functions. Okay, so, for example, if you have two functions, you could add them together, and this would be read as f plus g of x. It could also be written as f of x plus g of x. All right, and then it gives you a nice table of how that all looks. Okay, and so we will just get right to it. It says, for example 1, let f of x be 5x squared, g of x is x squared minus 4, and then h of x is x squared plus x minus 2. So one thing that you're going to need to do ultimately, if you have these quadratics, is check to see if they can be factored, okay? So as always, or as is usually the case, we have factoring coming into play one way or another, okay? So g of x could also be written as, thinking about that as difference of squares, that'd be a plus b times a minus b, so it could also be written as x plus 2 times x minus 2. And you'll see why that's important kind of later in the video. And then h of x. So for this one, we're thinking what multiplies to negative 2 adds to positive 1. So that'd be positive 2, negative 1. So x plus 2 times x minus 1. Okay. Like I said, you'll see why that's important later. All right, so for A, it says f plus g of x. That also just means f of x plus g of x. So we'll take f of x as 5x squared plus g of x is, I'm just going to use the unfactored form since I'm not like multiplying or dividing. So I'll just use x squared minus 4. So when I add those two together, I'm just combining like terms. 5x squared plus 1x squared is 6x squared. And then you have that minus 4. So that would be our rule. Or if you wanted to write that a different way, you could write it as 2 times the quantity 3x squared minus 2. Either way, okay. All right, let's look at a subtraction one. Subtraction is always a little bit more difficult than addition. I'm going to skip B just so I have more room here on C. So we're going to take g of x, which is x squared minus 4, minus h of x, which is x squared plus x minus 2. All right, so what is important when to remember when you're subtracting multiple terms is you just want to distribute that negative through, right? So you don't necessarily have to write it out, but in your mind, what you need to see here is negative x squared minus x and plus 2 when you're combining your like terms. At that point, yeah, we are just combining like terms. So x squared minus x squared is those cancel each other out. So our lead term here would be negative x. And then we have negative 4 and positive 2 make negative 2. So negative x minus 2, generally speaking, so g of x is x squared minus 4, and f of x is is 5x squared. All right, and just don't forget, this one's a little bit more obvious because there's only one term there, but don't forget if there are multiple terms that you're subtracting, you kind of distribute that negative through. All right, so overall, my rule would be x squared minus 5x squared would be negative 4x squared. And then we just have the minus 4. So you could write it that way. A lot of times they'll want that lead term to be positive. So you may want to, if MathXL wouldn't take that, you may want to factor out the negative 4 and write it as negative 4 times the quantity x squared minus 1. Sorry, plus 1. All right, and so moving on. Now let's get into some multiplication and division, okay? You have to be careful with the multiplication symbol here because there's another symbol kind of that we learn later that looks almost like that, but notice this is a little dot, so this is f of x times g of x. F of x times g of x. So f of x is going to be 5x squared. G of x is the quantity x squared minus 4. And I'm not going to use the factored form because, they're x plus 2 times x minus 2 is just going to multiply out to this ultimately. Okay. All right. So we're just going to distribute then, and we'd have 5x to the 4th minus 20x squared. All right, which would be fine, or could also be written as 5x squared. Well, I guess if we factored it out, we could just go back there. So I guess what they'd be looking for is this. All right, and we need to do one of these two division ones. Let's skip over to f. All right, so we're going to do g of x. So this means, so g over g over h of x just means g of x over h of x. All right, so g of x is equal to x squared minus 4. H of x is equal to x squared plus x minus 2. All right, so we will come back to why the factored form is important, because if you type this in, MathXL is going to tell you this is unsimplified, okay? So actually, since I already said that, let's just go through and see what I mean by unsimplified. All right, so we've already factored out g of x. We said it's x plus 2 times x minus 2. And then we said that h of x is equivalent to x plus 2 times x minus 1. All right, so these x plus 2, x plus 2 over x plus 2, that's just equal to 1 over 1, right? So really my final answer in simplest terms is going to be the quantity x minus 2 over the quantity x minus 1. So with division, that's where the factored form comes back into play. All right. Then we get into concerns about domain and range. When we perform operations on functions, we have to be concerned about issues with domain. And recall that domain is the set of all input values for the function. Okay. So domain questions. Could both positive and negative values be used for x? And that'll come into play when we have radicals and stuff. Or specifically square roots. 2, could 0 be used? And then 3, this is the one where we get into a lot. If you have a denominator, denominators can't be equal to 0, right? You can't divide by 0. All right, so example 2 is more of the same. So first thing we want to do is go ahead and go back those examples we did and think about what is the domain. All right, it doesn't ask me about domain and range, just domain. Okay, so if I have the function 6x squared minus 4, is there any limitation on what I could plug in for x? And the answer here is no, there is no limitation. So my domain would be all real numbers. If we wanted to name the range, we could just look at the graph, right? But all they're asking me for is the domain. Okay, again, we have just a quadratic, so there's no limitation on what I can plug in for x. Remember when we were working with quadratics a lot, we said it's pretty much a given unless it's like a real world scenario that the domain would be all real numbers. Okay, same kind of deal on D. Just it's not a quadratic, but you know, it's going to act similar. There is no restriction on what we can plug in for x. So domain again, all real numbers. So I guess when in doubt, you could guess all real numbers and you'd be right a lot of the time. Here's the only time, seriously, when you have to be careful for right now, for these examples, would be when you have denominators, okay? So, you know, you could plug in any real numbers for x except any that make the denominator equal to 0, okay? Now, we look at that and we know, you know, if you set x minus 1 equal to 0, then x can't be positive 1, okay, because you get positive 1 there. So here's how we say that. Domain is all real numbers except x cannot be 1, okay? And then you also have to think about before we cancel, okay? So x also could not be negative 2 because of this factor right there. X cannot be negative, x cannot be positive 1 or negative 2. All right, so these examples, these triad examples are very similar to what we just did. I'm trying to see if there's anything else that I should cover. I'll just do a couple more from here. I wanted to do a subtraction where we did have multiple terms we were subtracting. So let's look at B. And in this example, f of x is 2x minus 8, g of x is 2x plus 4, h of x is this quadratic, 2x squared plus 3x minus 2. And that's going to factor to, just kind of take a shortcut here. It would factor to 2x minus 1 times x plus 2. And remember on these, where the coefficient's not 1, the lead coefficient's not 1, you're trying to factor by grouping there. All right. Okay, so let's look at B. It says f of x minus h of x. All right, f of x minus h of x. So that'd be the quantity 2x minus 8 minus the quantity, and I'm going to go unfactored form here, 2x squared plus 3x minus 2. All right, so when you subtract, again, the only reason I wanted to cover this is because you got to remember to distribute that negative. You don't necessarily need to write all that out. You may want to, but you need to at least see in your mind's eye that when we distribute, we get negative 2x squared minus 3x and plus 2. So it flips all the signs. And then you're combining like terms, okay? So my lead term would be negative 2x squared. Then my x term is going to be positive 2x, and then that's a negative 3x, so minus 1x. And then I have a negative 8 and a positive 2, which together make minus 6. All right, so I will just leave that one there. I'm not going to worry about if it can be factored or not. I'll just leave that as my final answer. And my domain, just a regular quadratic, no denominator, is going to be all reals. No restrictions on what we can sub in for x. All right, and so I also wanted to do f just because, actually let's do e. Let's do e, g of x over h of x. All right, so g of x is equivalent to 2x plus 4, the quantity 2x plus 4. H of x is equivalent to 2x squared plus 3x minus 2. Okay, and if we don't know the factored form, then we are not going to, we're not going to see that this reduces. So let's also factor this one to 2 times the quantity x plus 2. And then from earlier in the video, when I factored this out, we got x plus 2 times 2x minus 1. Okay, so it's kind of hidden in there, but now we can see that x plus 2 goes into both expressions. And so my final answer is going to be just 2 over the quantity 2x minus 1. Then you want to be careful, like you can't cancel these to 1, right? Because this is a full factor. 2x minus 1 kind of is the factor. And then my restrictions are anything that I could sub in here or here that would make that equal to 0. So we're going to say all real numbers except x cannot be equal to, this one would give me 1/2. And this one would give me -2. X can't be 1/2 or -2 because it makes my denominator equal to 0. All right, so the last thing that you will look at in this lesson are function compositions. All right, so this is what I was talking about earlier when we did the multiplication. Don't mistake this. It looks like fog x, but you say f of g of x, okay? F of g of x. So just be careful there. This is not the same as f dot g of x, right? That's something different, okay? Those things do not mean the same thing. So just wanted to reiterate to be careful there. All right, so then they give me g of x rule, an f of x rule, and h of x rule. H of x wouldn't factor, so we're not going to worry about any of that. It wouldn't really apply to this anyways, okay? So I'm going to show you a couple of approaches here. I think they kind of outline that in the table. Well, I guess they only show you one way, okay? So let's do it their way first, and then go from there, okay? So this means f of g of x, or sorry, f of g of 3. So the other way you could write that is f parentheses g parentheses 3. I said 3 and I wrote x. All right. So if you wanna do it the textbook way, you could find g of 3 first. So g of 3 would be take this rule and replace x with 3. So 5 times 3 gives me 15. So once I have that, now I know g of 3 is 15. So I'm really finding f of 15 is another way to say this, right? So take our rule here, x minus 8 and 7, 15. And then 15 minus 8 gives me 7. Okay, so that would be one approach. Another approach, if this makes more sense, would be like this. So what you could do first is you could find f of g of x, all right? So step 1 could have been find f of g of x, which would look like this. So we'd take our rule for f of x and sub in our rule for g of x, which would look like 5x, take away 8. All right, and then after that, step 2, I'm just not going to do this one. So step 2 on that one would be, now we can find f of, g of 3. which would be now here's our rule for f of g of x, and now sub in 3. So it'd be 5 times 3, take away 8. 15 minus 8 gives me 7. So I'd say whichever one of those two makes the most sense, I would stick with that one. Okay. Let's do maybe just, one or two more for practice. So I'll do C, and then E looks a little more abstract. So yeah, we'll just do that. I'll do C and F. That's what I'll do. All right. So what if we have F of 10? So I'll use method 1 on this one. Okay, and then I'll use method 2 on maybe the next one. All right. So f of 10. So step 1 would be to find f of 10. So that just means take your f of x rule and replace x with 10. Let me wait till that pops up. Maybe. There we go. So it'd be 10 minus 8 is 2. So that tells me then I'm really just finding f of 2, right? Because f of 10 is 2. So that would be take 2, take away 8, get negative 6. Negative 6. So that'd be by method 1. The other way you could do it, just to kind of talk you through it, find f of x, right? So you could just take your x minus 8 rule and sub it in, for x. So x minus 8 would be, x, take away 16, right? And then you plug in 10. 10 minus 16 gives you negative 6, if that makes sense. Okay. All right. So E and F look a little bit different, a little more abstract, not subbing in a number there, but subbing in a variable. Okay. So let's just do example F here with method 2. Okay. And then I'll talk you through method 1, and that'll kind of conclude our video. All right. So my step 1 here is going to be to find G of H of X. G of H of X. Okay, so that is, we take, our rule for G of X and sub in this rule for X, right? So that would be 5 times the quantity X squared plus 3. I'm kind of running out of room here. I think I have more space. So we can leave it as is or distribute to get 5x squared plus 15. Now that I know that, I could now find G of H of A. Which would be, now we take our new rule and sub in A where we had X. And all that's going to do is replace the variable x with the variable a. Okay, so by method 1, what we could have done instead would have been to have found h of a. Okay, so let's see, I'm trying to find the rule. So h of a would just be a squared plus 3. And then we sub that into there. So we end up with the same thing, 5a squared plus 15. Okay, so this, this can be one of those lessons that maybe looks a little bit easy when you're watching it on video, but kids kind of just tend to have a little bit of trouble with this. So I assume you'll have questions. So I'm building in a review day for our next class. As always, hope this helps, and let me know what kinds of questions you have on the practice.